Hello everyone, I'm Wang. I'm representing ProSelfLC, which is a joint work of me, Yang, Anil, David, and Neil, and it's a joint work of the CAI University of Oxford and Queen's University, Belfast. So first, the core questions we study here is in CFLC, how much should we trust a learner to leverage its own knowledge? In the prior work, the trust score is fixed and updated stage by stage, and instead we propose ProSelfLC, which modifies the target progressively. And another question is that should we penalize a low entropy status or reward it? First of all, I would like to introduce the definition of label in this work. We care about the semantic class, like which defines which training classes the input belongs to, and the second definition is a similarity structure, which cares about how the input is similar to all the training classes. The label correction include OR, output regularization, and label correction. Output regularization include label smoothing and confidence penalty, and it means the only smoothes the similarity structure here. And for the label correction, it is divided to self-label correction and non-self-LC. There are differences is that non-self-LC requires auxiliary learner. Here, the epsilon is important because it defines how much a predicted label is trusted. The existing target modification is that OR only naively penalize confidence output without using as extra learner the non-different self or other learners, while non-self-LC relies on accurate auxiliary models. Self-LC is the most appealing because it exploits its own knowledge and requires no extra learners. The only thing we need to improve is that how much should we trust a learner to leverage its knowledge. And here is an overview of existing self-LC method and the requirement of improving self-LC. We want it to be end-to-end trainable and reduce the extra cost, and also modify the targets progressively and adaptively. The second question we study is that should we penalize or reward a low entropy status? This question is derived from the fact that OR method penalize low entropy while LC reward a low entropy status. So that is why we ask, should we penalize or reward the low entropy status in this work? And our proposed ProSelfLC, it contains two key components. One is the GT, which increases the trust score of the model as training time increases, and LP is only depends on the prediction confidence of the specific input. And here is the case analysis is that GT is high in the later phase and LP is high when the prediction is confident. So we only modify the semantic class in the later phase and when P is confident. And here is our operation study about our design choices, like why we choose epsilon to be accumulation of GT and LP instead of only using the GT or fixing the epsilon. And here is the training results. We show some training results. The learning dynamics of different methods. ProSelfLC is the best because it has the lowest wrong fitting, and it improves this. It does the semantic class correction the best, and also so that is why it has the best generalization performance. And here is the entropy results. We find that LP ProSelfLC has the lowest entropy on both subsets, but the performance is the best. So this demonstrates that we can or we should reward a low entropy status. The only thing we need to care about is that the low entropy status should be correct because of ProSelfLC corrects the labels. So it's a reward towards a correct low entropy status. And here is the summary of method. ProSelfLC is the first method to trust self-knowledge progressively and adaptively, and we defend entropy minimization principle, and our code is here. Feel free to contact us, and thank you for your attention.